All right, we finished off the lecture yesterday by discussing long division. Yeah. And we touched a little bit on remainder theorem, but unfortunately time caught up with us. So we'll try and complete course book 1 by today. Meaning we'll discuss remainder theorem, factor theorem, laws of exponents, and manipulation of surds. Try and do this quickly. So let's again go through remainder theorem. How do we? If a polynomial fx is divided by x minus a, then we can calculate the remainder by substituting a into fx. So let's have a look at this. We are dividing 5x squared divided by minus 4x plus 3 and divided by x minus 3. So when we do the long division, we get a remainder of 36. Oh, by the way, what is this expression called? You remember? There's a name I gave it to it yesterday. That's called the dividend. And x minus 3, what is x minus 3 called? The divisor, and 5x plus 11, the quotient. Now, this is one way of calculating the remainder. We can do long division. Or we can use the remainder theorem. And the remainder theorem says, we start working with the divisor. If we divide this, we work with the divisor. We make the divisor equal to 0. If x minus 3 is equal to 0, what's the value of x here? Positive 3. X is equal to positive 3. Now, the remainder theorem says, in order for me to work out this remainder of 36, I'll substitute x equals 3 into 5x squared minus 4x plus 3. Let's check. Substitute 3 into x quickly. What do you get? Substitute 3. Quick. So that's 5 times 3 squared minus 4 times 3 plus 3. Long division says we get remainder of 36. Substitute 3 to fx, what do we get? Whoa. 36. Yeah, I think we get 36, eh? So if I substitute 3, so 3 squared is 9, 5 9 is 45. Minus 12 plus 3. Get 36, eh? Which means there is an easier way of finding the remainder apart from long division. Yeah? How can we find the remainder? By using the remainder theorem. Make the divisor equal to 0, solve for x, and substitute the x value into the function. That gives you the remainder. But if you need both the remainder and the quotient, then you will need to do the normal long division. The remainder theorem does not give you the quotient, just the remainder alone. So here's another example. Find the remainder when gx is divided by x plus 2. What do we start off with? We make the divisor equal to 0. We get the x value. And then, to find the remainder, we substitute the x value into gx. So the remainder is 44. Can we confirm that using long division? Let's do long division quickly. Let's see if we can get okay. Negative 2x cubed divided by x. We get negative 2x squared, and we multiply it to both. We'll subtract negative 2x cubed minus negative 2x cubed, 0. 3x squared minus negative 4x squared, positive 7x squared. That will bring the minus 7x. 7x squared divided by x, positive 7x. We'll multiply positive 7x to both. That gives us and we'll subtract. What do we get? 7x squared minus 7x squared minus 7x minus 14x. Divide. That gives us minus 21. And we're multiplying minus 21 to both. Minus 21 times 2. What do we get? Minus 21x minus a negative 21x. 2 minus a negative 42. Was that the remainder we got with the remainder theorem? Yes. Now the remainder theorem only gives us the remainder. The long division gives us both the remainder and the quotient. Now later on, you will see that you will still need this long division for some other purpose. But at least we know, in order for you to find the remainder quickly, we can just use the remainder theorem. Okay. What if the remainder is equal to 0? I think we discussed this yesterday. 128. If we do this, 128 divided by 4, 4 into 12, 0. Bring the 8 down. 4 into 8. The remainder is 0. What conclusion do we make? Yeah, if the remainder is 0, then automatically 4 is a factor of 128. And we can even write 128 like this. 128 is equal to 4 times 32. We agree? Only if the remainder is 0. And that takes us to the factor theorem. The factor theorem says if the remainder f of a is equal to 0, then the divisor is a factor to the dividend. Only if the remainder is equal to 0. And the divisor is a factor of the polynomial or the dividend. So we've done a long division. X into x squared gives us x, and then we are multiplying x to both of them. So that gives us x squared plus 5x. Please put them in a bracket and subtract. When we're subtracting x squared minus x squared, 0. Yeah? 2x minus 5x minus 3x. And then we'll bring the minus 15 down. And then we'll repeat the same process. Negative 3x divided by x gives us negative 3. And we multiply negative 3 to both. Gives us 3x minus 15. And in this case, the remainder is equal to 0. So what is our conclusion here? What's the factor? X plus 5 is a factor of, and we can even say x squared plus 2x minus 15 is equal to x plus 5 multiplied by x minus 3. Make sense? That's another way of factorizing. Finding factors. Okay. Now, if we use the factor theorem, x plus 5 equals 0. So that means our x value is negative 5. If you substitute negative 5 into fx, someone look it up, what do you get? Okay, let's do it together. What does this give us? Negative 5 squared? 25, eh? What is this? Minus 10. Minus 15. What do we get? 25 minus 10 minus 15 gives us 0. And what does this 0 represent? The remainder. And if the remainder is 0, what's our conclusion? X plus 5 is a factor. Okay, some examples. This is extracted from your course book. We are asked to factorize 2x cubed plus x squared minus 15x minus 18. Let's do it together. Two x cubed minus 18, eh? We have a problem here. We are not given any hint at all on how to factorize this. If it is x cubed, then that means we need to find 3 factors. If it is x squared, just 2 factors, eh? In this case, you need 3 factors. So how do you find the three factors? No hint at all. At least we know the factor theorem. If we substitute a number to this and we get a remainder 0, that should help us find one factor. Now, what number can we substitute? What we will do, we will look for the factors of the constant term, negative 18. What are the factors of negative 18? 1, negative 18, negative 1, 18, 2, negative 9, negative 2, 9, 3, negative 6, negative 3, 6. We'll try and substitute one of them. But at least we are told, try and substitute negative 2 here. Do you get 0? Quickly. So, h of negative 2. Let's do that together. This gives me negative 16. Someone solve this? What do we get? Negative 16 plus 4 plus 30 minus 18. We get 0. Agree? So substituting negative 2 gave us the remainder 0, eh? Do we agree? What x value did we substitute? X equals negative 2. Now, if we take negative 2 to the left, what does it become? So that means x plus 2 is a factor. So now we've got one factor. But we know that hx has got to have, at least we know one. How do we find the other two? Well, we can keep substituting the factors of negativity, but that can be quite a long exercise. However, we can do this. We can divide the dividend divided by the divisor that we now have identified. Since we found the first factor, we divided the dividend divided by that first factor. What should our remainder be equal to? 0, eh? To agree with the factor theorem. So we found the remainder 0. We've now got the quotient. So that means hx, which is this, is equal to the divisor times the quotient. And after last week's lecture, I expect you to be able to factorize this. We factorized it. Now, this is always coming in the test and final exam. You are given a cubic function, and you're asked to factorize it. Let's go through the steps quickly. Firstly, use the factor theorem to find the first factor. How do you do that? Substitute the factors of the constant term. Whichever gives you 0 should be the basis for finding the first Once you found the first factor, then definitely you still need to do long division. Yeah, because the long division helps you identify factor times the quotient. And usually you'll be required to factorize that quotient. So, let's do number 3. Factorize 3x cubed minus 11x plus 12x minus 4. What are the factors of negative 4? Negative 1, 4, 1, negative 4, negative 2, 2, eh? Which of these can you substitute into fx to give you 0? Which one? Let's try negative 1. Yeah? Substitute negative 1 here, what do you get? Quickly. Substitute negative 1. Bad. Here, factors are negative 1, 4, 1, negative 4. So substitute negative 1 in. What does that give you? Does it give you 0? Yes, no? Does it give you 0? No, eh? Yes, no? Okay, so this doesn't give me 0. Okay, so try out f of 1. Try out f of 1. I want one that gives me 0. Does f of 1 give you 0? Yes? Okay. So we've got a remainder of 0. Once I've done this, what does that tell me? Something is a factor. What is a factor? Not 1, not just 1. What x value did we substitute? Take the one to the left. Yeah, therefore x minus 1 is a factor. Set? We found one factor. Now, we are required to fully factorize. This we expected to have 3 brackets because it's cubic. So tell me, what should our next step be? Now that we've found the first factor. Yeah, we'll have to do long division. Go and do that. Do the long division. Oh, by the way, what should the remainder of this long division equal to? It should equal to 0. So check. Let's see how good you are with the long division. The remainder should be 0. If it's not 0, it means you made some mistakes or not. Quickly. I need the quotient. I need the quotient. Well, I know that the remainder should be 0. 3x cubed divided by x gives me 3x squared, and I multiply it to both. Squared. Subtract them. This will give me 0. What do I have here? Negative 11x squared minus a negative 3x squared. What do I have? Negative 8x squared. Bring the plus 12x. This divided by x. Negative 8x times both. Subtract them. What do we get? Right? This minus this gives me 0. 12x minus 8x. 4x. I'll bring the minus 4 down. 4x divided by x gives me 4, but positive 4. So multiply positive 4 to both. Subtract them. What do I get? So that's correct. So once we've done that, so that means we'll rewrite this is now equal to the divisor times the quotient. And I expect you to be able to factorize this. What are the factors? Anyone? Can either use the trial and error or grouping. X. What is this? Okay, let's just 1, 4, 1, 24, 2, 2. Okay. 3x squared. So you will have to use, I think for this one, we'll need a separate method of factorizing because we will use the quadratic formula. So let's not factorize this because it's going to be a little bit complicated. But again, the normal steps. find the one factor by using the factor theorem. How do we do that? Substitute the factors of the constant, whichever gives you 0, is the basis for your first factor. And after that, what do you do next? Long division. And we know that with the long division, the remainder should be equal to 0. If the remainder is not equal to 0, then check your steps again. Okay, let's move on to exponents. Laws of exponents. There are a total of 8 laws. Follow along with the first one. Base, exponent or power. Okay, law number 1 says, if you are multiplying two base index and the base are the same, what do? We can add the powers. Only if the base are the same. Only if the base are the same. 2 to the power 3 times 2 to the power 4 is equal to 2 to the power 7. That's with multiplying. Law number 2, if you're dividing and the base are the same, what do we do to the powers? Subtract the powers. Yeah. X to the 8 divided by x squared, because the base are the same, you can subtract the powers. Law number 3, if we are raising a base index to another power, we can multiply the powers. X squared cubed will multiply the powers. A to the power 2m times to the power 4 will multiply the powers. A to the power 8m. Law number 4. A times B, everything to the power m, I can break it up into A to the power m times B to the power m. Now, be careful with law number 4. Because law number 4 does not work with addition, it does not work with subtraction. What I'm saying is this. Okay, let's do this. 2 times 3 squared, law number 4 says I can break it up into 2 squared times 3 squared, eh? What does this give me? 6, eh? 6 squared. What's 2 squared equal to? 4 times 3 squared. What? 6. Breakfast, man. 4 times 9. 6 squared. Now I said law number 4 does not work with addition or subtraction. So what I'm saying is this. This is not equal to no. Check. What does this give? 5 squared, 25. 2 squared. 2 squared is what? 4 plus 3 squared. 9. 4 plus 9, 13. So law number 4 does not apply with addition. It does not apply to subtraction. But it applies to multiplication and division. Okay? So when I say that here, some people will say, oh, X squared plus y squared. No. So that doesn't agree with law number 4. Eh? Law number 5. A to the power 0 equals 1. Calculator, please. 55 to the power 0. Calculator. 5 to the power 0. 1. 11 to the power 0. 1. Okay, there's a restriction here. What's the restriction to the law? A should not be equal to 0. Now calculate the 0 to the power 0. 1, is sure. What is your calculating from? Yeah, it should be on that. That's why the restriction is there. A should not be equal to 0. Later on, when you do high-level maths, then how many of you want to do high-level maths? That's it. But later on, for those of you who love maths, are crazy with maths, like some people, then you do 0 to the power 0 and do some calculation. Yeah? But that's law number 5. Any number raised to the power 0 will give you 1, except 0. Notice only x is raised to the power 0. So 1, 2 comes 1, 2. Law number 6. A to the power negative n. Whenever the power is negative, automatically it means 1 over. X to the power negative 3, it's 1 over x cubed. X to the negative 3 to the negative 2. 1 over 1. Can you just check this with a calculator? 3 to the power negative 2. So that's law number 6. Law number 7 and 8 are a little bit tricky. We read this as the nth root of a, or a to the power 1 over n. For example, cube root of 27 is equal to 27 to the power 1/3. Now, if you have a calculator, see if you can do this. Cube root of 27. Your calculator has a function, cube root. Yeah. And let me just... It's this function, eh? Yeah. In order for you to activate that, you have to press Shift. Three, eh? But I want you to enter this also in the calculator. 27 to the power 1/3. It should give you 3. You get 3 or do you get 9? Do you get 3 or if you get 9? Remember what I said last week called generator. The calculator works on the concept of garbage in, garbage out. To give your calculator rubbish, will also give you back rubbish. 27 to the power 100. Did you get 9? Yes. That means you gave the calculator rubbish. Now, 27, there's the power function there. Put 1/3 inside the brackets. 3, yeah, you should get 3. Whenever the power is a fraction, put it in a bracket. You get it or not? Yes. Fourth root. Yeah, so 4 shifts. Then law number 8. Don't really want to dwell too much on law number 8. How much time do you have left? So question 1. 3 squared times 3 to the 4, what do you get? Simplify it. What do we do? We're multiplying them and the base are the same. What do we do here? Add the powers. Add the powers. So that gives us 3 to the power 6. Question 3. 2 to the 8 divided by 2 cubed. What do we do to the powers? Minus, so we get 2 to the power 5. Eh? Question 5. 3 squared, everything cubed. We apply law number 3. It says, what do we do here? We will multiply the powers, yes. So that gives me 3 to the power 6. Well, let's just confirm that. Calculator, what's 3 squared? And 9 cubes? 81? No, not 81. 9 cubes. 7 to 9, I think. Yeah? So check. We multiply this. 3 to the power 6. 3 to the power 6 should give you 7 to 9. Yes. Question 7. What answer do we get? Question 7. 1. Agree? Wait. Okay, well, hold on. Okay. It's here. 5 times 2x squared, everything to the power 0. Do you get 1? I disagree. And 1 times 5 is equal to 5 and 1. This will give me 1, eh? Is the 5 included in the power? No. So this gives me 1 times 5. Gives me 5. Okay, I want us to do number 14. Number 14. X to the 4 divided by 8x squared, y. Everything to the power negative 2. I think law number 6 says whenever the power is negative, we use 1 over it. We can apply that here. But before we touch this, okay, let me restate that. We can use 1 over, but there's a better option available for us, and that reaps the same result. Rather than using 1 over, I can make the power positive and invert this. It'll still give me the same result. And I think that's a better option for us. So let's invert this, make the power positive. So that means it will still give me the same result rather than using 1 over. Now, law number 4 says I can raise each one of them to the power 2, but there's a better option for us. Can we simplify what's inside the bracket first? Yeah, we can make some cancellation. Yeah? So I cancel 2 and 8 gives me this x squared, when this x to the 4, that leaves me with x squared in the denominator. 4y. Now this is so much easier for us. Then I can raise everything to the power 2. Meaning 4 squared, y squared, over x squared squared. So this gives me y squared over, multiply the powers. X to the power 4, yes. I want us to finish off with this. Let's see if we are able to cover all of this. Simplifying manipulation of surds. Another name for surds is an irrational number. Can we clarify perfect squares? What numbers are called perfect squares? Remember what numbers are perfect squares? Okay. 4 is a perfect square. What else? Is 8 a perfect square? No, it is not. 9 is a perfect square. What else? 16, 25. 36, because they are a result of some numbers squared. So we classify them as perfect square. Now, there are complicated surds, and we need to break it down as the product of the largest perfect square and a simplified surd. For example, let's go to 18. What numbers give to multiply to give 18? 9 and 2, 6 and 3. Now, which pair has a perfect square?